Hey, in this video we're going to go over logarithms, and as a starter I'm going to link my exponents video in the description because you need to know how exponents work in order to understand logarithms properly. So first, if you have an exponent, let's say 2 to the power of 5, what you're going to do is multiply 2 by itself 5 times. So you do 2 times 2 times 2 times 2 times 2. If you put this on a calculator, or if you already know it, it should be 32. So that's what 2 to the power of 5 is. Okay, now if I ask you the opposite, 2 to the power of x is equal to 32. Basically, I'm asking you, 2 to the power of what gives you 32? Your answer, just because we did this, is equal to 5. So you'd say x is equal to 5. But we knew this answer only because we just solved this. If I gave you a brand new question, logarithm of, let's say, base 10 of 1000, what this is going to be is you're going to have to find out 10 to the power of what equals to 1000. So what the logarithm does is it gives us the value of x. So you can think of it as a loop. So log of base 10, so 10 to the power of x gives you 1000. 10 to the power of x gives you 1000. Kind of think of it as a loop because that's how a logarithm works. So another example, this example actually, if you solve for it, if you plug this in a calculator, you would get x is equal to 3. Once again, these examples are easy. You can find them yourself just by looking at it. But if I give you a very tough example that you would not be able to tell what the answer is, you would have to plug it in a calculator, or you'd have to find some other way of finding what x is, and that's when the logarithm comes handy, because you would put this in a calculator and the answer would be 3. Okay, let's do one more example. So if I said, what is logarithm base pi of pi to the power of 3? Okay, once again, this is going to be x, some exponent that we do not know. But then let's rewrite this in some other way. Let's remember the loop, which I already mentioned. So pi to the power of x is equal to pi to the power of 3. So let's write this down. Pi to the power of x is equal to pi to the power of 3. Okay, by looking at this, can you tell what x is? Yes, pretty simple. X is equal to 3. Once again, this is quite easy because you rearrange it and then this makes it super easy. Some other question that you might get is the opposite. You might get something that looks like this, but because of how complicated it is, you have to go to this format to plug it in a calculator. Okay, let's do one more example before we move on, of going from this format, the one that I'm squaring in yellow, to the one in green text. So how would you do that? Let's say I ask you a question, 2 to the power of x is equal to 1024. Okay, by looking at this, probably too hard, you probably can't do this. Is there another way of doing this? Yes. So what can you do is first you'd say, okay, let's write down our circle. So 2 to the power of x is equal to 1024. So log 2 to the power of x is equal to 1024. Remember this loop once again because it is super useful. And if you plug this on a calculator, you should get the answer, which is 10. So x is equal to 10. And that is your answer for this question. Now let's move on to a few more examples where we keep doing this until you kind of understand how it works. Okay, question number 1. What is log of 1000? Okay, first you might say, where is the base? Where is the bottom number that we would usually go to find the loop by? Okay, if you do not see a bottom number, our default is going to be 10. This is something that is known for logarithms. If you don't see a bottom number, we assume it is 10. Okay, after that, now you might ask yourself, what is the answer to this? Let's call it x because we're trying to find it. You tell yourself, okay, let's follow the loop now. So 10 to the power of what gives you 1000. 10 to the power of what, in this case, that variable is called x, is equal to 1000. And then you can say, okay, 1000 can be written as 10 to the power of 3. So 10 to the power of x is equal to 10 to the power of 3. And okay, so x is equal to 3. Once again, if you plug this on a calculator, this would give you the answer of 3, which we got this way over here. But I'm trying my best to not use a calculator in this case. Okay, question number 2, logarithm base 2 of 32. Okay, once again, let's first make it equal to x, because that's what we always do. And then let's follow our loop. So 2 to the power of x is equal to 32. So 2 to the power of x is equal to 32. Okay, after that, how do you represent 32 as a base of 2, this would be 2 to the power of x is equal to 2 to the power of 5. Once again, I know this because I've done it before, but usually for a question like this, you probably might need a calculator. But yeah, and then obviously if you already have this, they look the exact same, so x is equal to 5. Question number 3, so same thing once again, let's first make it equal to x. After that, let's do our loop. So 3 to the power of x is equal to 27. So 3 to the power of x is equal to 27. After that, okay, how do you represent 27 as a power of 3? This will give you 3 to the power of x is equal to 3 to the power of 3. Okay, after that, looking at this, you can easily tell that x is equal to 3. Okay, pretty simple so far. Let's keep moving on. This one, you first might look at it and say, okay, why is it 5 to the power of 7? This is actually a bit more difficult. But no, this is actually a lot easier, and we should have done this first as a starter example before the other ones. But I'm doing it second because you would probably see these ones before you see something like this. Okay, but yeah, this is actually a lot easier because it already pretty much gives you the answer. If you have the same numbers here and here, the answer is always a number on top. Let's actually show this. So if I say this is equal to x, let's follow our loop again. So 5 to the power of x is equal to 5 to the power of 7. So 5 to the power of x is equal to 5 to the power of 7. By looking at this, quite easily you can tell that x is equal to 7, and we are done. So one step that we kind of ignored is going from here to here, because we already have this as a power of 5. We don't need to find what it is as a power of 5. Okay, so that's what makes this a lot easier. But once again, if you know this loop, this technique of finding the loop, you can find any of these and you don't even need to know the tricks, because at that point, it's just memorizing it for no reason. But the trick is here that if you have the same number as the base and the same number as the base of the number, then the exponent is going to be your answer. Okay, so that's pretty much it. And that's why we got x is equal to 7 here. Question number 5. So same thing here. This one is super easy. First, we're going to do our loop, which first what we're going to do is equal to x. And then pi to the power of x is equal to pi to the power of 4. So pi to the power of x is equal to pi to the power of 4. Okay, what is x? By looking at this once again, x is equal to 4. So x equals 4. And we are done. Okay, question number 6. This time we have a square root of 2. Okay, first you might say this is kind of weird to begin with. But what you should know is that if you have a square root of any number, square root x, this is the exact same as having a fractional exponent of 1/2. So this would be x to the power of 1/2. Same with the cube root of x. If you have the cube root of x, whatever thing or number is here, this would be the denominator of the fraction. So this would be x to the power of 1/3. Okay, so once again, whatever number you have on the root is going to be the number on the denominator of this exponent. You should already know this, but I'm just reviewing it just in case you forgot it. But yeah, so considering that now, we can write first the x, so write that down, and then use our loop. So root 2 to the power of x is equal to 4. So root 2 to the power of x is equal to 4. Okay, now what can we do? First, this requires a bit of experience because I know it, because I've done it before, but I know that both of these can be written as powers of 2. So root 2 can be written as 2 to the power of 1/2, just like we said, because it has a square root. So I'm going to write this as 2 to the power of 1/2, all to the power of x is equal to, and then 4 can be written as 2 to the power of 2. Okay, pretty simple so far. And then using our exponent rules, if you have an exponent to an exponent, we can multiply them together. So 1/2 times x, I'm going to write it down here, 1/2 times x is equal to x over 2. Okay, so now we know that this can be written as 2 to the power of x over 2 is equal to 2 to the power of 2. And our goal here was to have the same base, because once you have that, these exponents have to be equal. There's nothing else that can happen for these exponents to look different. So now we know that x over 2 is equal to 2. These exponents must be equal because once again the base is equal. So there's no other scenario where these exponents are not going to be equal. But yeah, so we can write this as x over 2 is equal to 2, and then solve for x now. So you multiply both sides by 2, basic algebra. So multiply by 2, these cancel, you get that x is equal to 2 times 2, which is equal to 4. So this one was a tiny bit more complicated, but it's the exact same steps. First start with a loop and work your way to finding what x is. That's it. Question number 7. Here we have an easier one again. So first make it equal to x. That's always your first step. After that, you do the loop. So 6 to the power of x is equal to 6 to the power of 2 over 3. So I'm going to write this as 6 to the power of x is equal to 6 to the power of 2 over 3. And obviously, once again, by looking at this, you can tell that the exponents have to be the same because the bases are the same. So x is equal to 2 over 3. Just by looking at it. You look at the exponents, you say, okay, they have to be equal. So this is our answer. That's it. Question number 8. This one is easy once again, but there's a fun fact about this. I'll tell you about it after we actually solve the question. So same loop once again. Just because you saw an e, this is actually not a variable. It's kind of a constant, just like pi. It's one of those numbers that never end. So we abbreviate it into a letter instead of having like a never-ending number. So first make it equal to x. After that, e to the power of x is equal to e to the power of 7. So e to the power of x is equal to e to the power of 7. After that, pretty simple. Look at the exponents. Since the bases are the same, the exponents must be the same. So in this case, x is equal to 7. And we are done. But the fun fact is, if you have log base e, this is also called the natural logarithm. So instead of saying log base e, I'm going to write the ln, ln, I'm going to actually write this, but ln, this is what the logarithm of e is. And then in brackets, say the same. So e to the power of 7. And then this is actually the exact same answer. This would be equal to 7. Because once again, when you write ln, we are assuming that this is log base e. It works the exact same way, it's written differently. That's the only thing about this, but it works the exact same way and you do the exact same steps. So yeah, that's it for this video. I hope you understood. If it helped you, leave a like because it helps me. But yeah, that's it.